Good morning children. Yes, today in this section we are going to continue the problem solving in Unit 5 Mensuration. In our last class we have started newly with the topic of cubes and cuboid. In that we have discussed about the cuboid and we have solved the problems based on cuboid, isn't it? Today in this class we are going to discuss about cube. Okay, as like a cuboid, what we discussed about the cuboid. Okay, after the class have you seen the things around you? What are the shapes of cuboid? I said some example: fish tank, match box, or your book, textbook or notebook, pencil box. This will be the some practical example for cuboid. Likewise, cube. Cube is also a solid with 6 faces. Cube is also a solid with 6 faces. For example, see here. This resembles the cube shape. Die. We will play that dice. Okay, it will be also in the cube shape, a single die. If you see means it has 6 faces. The number also there on the die. It is also the example for cube. Okay, so we are having a cube. But how many faces for a cube? 1, 2, 3, 4, 5, 6. 6 faces for the cube. And each face of the cube. In the cube, each face is in the shape of a rectangle. Here in the cube, each face is in the form of a square. Each face is in the form of a square. Okay. So see cube. Each of the 6 faces, cube is a solid, and each of the 6 faces of the cube is a square. Each of the 6 faces, all the 6 faces resembles the same. But in the cuboid, opposite faces are identical. Okay. Opposite faces are identical. But here all the 6 faces are identical because it is a square. We know the property of square. What is square? Square has 4 sides and all the 4 sides are equal. Okay. So each face here resembles the square. Means all the 6 faces are identical and each face is in the form of a square. Okay. This is a cube. Now see here we are going to see about the total surface area, lateral surface area of the cube. Okay. Total surface area. Total surface area includes all the faces of the cube. Total surface area includes all the faces of the cube. How many faces for the cube? Is 6 faces are there. So 6 into area of one face. Okay. Adding all the faces separately, just we can take 6 into area of one face. What is the area of one face for cube? The one face is in the shape of square. We know what is the area of the square? Is what is the area of the square? Side into side. If we take the letter A, if the side has A means we can take it as A square. A into A square. But nothing measured is given means area of the square can be taken as side into side. So 6 into area of one face. Here each face in the form of the square. So 6 into side into side. Side into side we can take it as side square. So the total surface area of the cube is given as 6 into side square units. Okay. Now the lateral surface area. The lateral surface area. How we will calculate the lateral surface area? The lateral surface area does not include the top and bottom faces. The lateral surface area does not include the top and bottom faces. So totally if you remove from 6 faces, 2 faces, how many faces are there? 4. So we have to calculate the area of other 4 faces. So 4 into, and all other 4 faces again it is in the form of square only, no? So side into side square. So the lateral surface area is given as 4 into side square units. Okay. Now length of the diagonal. What is the length of the diagonal of the cuboid? L square plus B square plus H square. There we have separately length, breadth and height. But imagine here, see in the cuboid, what is the length? The length is equal to breadth. The length is equal to breadth. The breadth is equal to the height. Isn't it? Because it is a square shape. It is a square shape each face. So the length, breadth and height here will have the same value. So we can take the diagonal as 3 into side square. 3 into side square because 3 sides are same only. So 3 into side square. Now, so square root of, we know that then we are having L square plus B square plus H square. Here all are equal to side square. So how we will add? 3. 3 square root of side square. 3 into square root of side square. But anything inside the square root, if we have the square value once, we can take it out. Isn't it? We can take it out. For example, root square root of x square is square and square root are reciprocal function. Maybe we can cancel and we can take the square root. That can be taken as x. In the same way, side square, for the square root is common for 3 as well as side square. If I take the square root separately for side square, it will take as side into root 3. So shortly we can take the formula, the diagonal of the cube as side into root 3. If the side value we know means, we can get the proper value for the diagonal. Okay. Now, volume of the cube. Volume, I already said the capacity. The capacity is based on the base area and height of the cube. The capacity is always based on the base area and height of the whatever the object is given. Here we are speaking about the cube. How the base area of the cube will be? It is in the form of the square. So, what is the area of the square? Side into side. Into height. Here the height is also the same value. Okay, because the length, breadth, height, everything is here same. So we can take it as side into side into side. Simply we can take it as side cube. We can take it as side cube, cubic units. Okay, so as like the cuboid, here also we are having some formulas. Okay, recall once. What is the total surface area? Total surface area is equal to 6 into side square square units. 6 into side square square units. What is the lateral surface area? Lateral surface area is equal to 4 into side square square units. 4 into side square square units. Length of the diagonal. Length of the diagonal is equal to side into root 3. Length of the diagonal is equal to side into root 3 units. And finally, the volume of the cube. Volume of the cube is equal to side cube cubic units. Okay. So these are the things you have to remember about the cube. Now we are going to solve the problems based on this formula. Okay. So let us go to the exercise problem now. Now we will solve the first example based on cube. See, the question is a direct question, clear question. Find the total surface area, lateral surface area and length of the diagonal of the cube of side 5 cm. For a cube, they gave the side as 5 cm. Just we have to find the total surface area, lateral surface area and length of the diagonal. How to find this? Is we have to read the formulas first clearly. We have to keep in mind the formulas clearly. Okay. We know how the formula came. We understood the way of deriving the formula. But here, if you memorize and keep the formulas in your mind only, we can directly apply the formula and get the answer. So before solving the problem, first be strong, enough strong in the formula. Okay. Now first, given. What is given in this question? Only the side of the cube. What is the side of the cube given? Side is equal to 5 centimeter. The side is given as 5 centimeter. What are the things we have to find? Total surface area, lateral surface area and length of the diagonal. First we will find the total surface area. Okay. So total surface area. Otherwise, in short form, we can say it as TSA. That is the total surface area. So remember and tell me what is the formula for total surface area? Yes, total surface area include all the 6 faces. It is the glue. So 6 into area of the side, isn't it? So 6 into side square. 6 into side square square unit. This is the formula for total surface area. Yes, good. What is 6? So 6 is a number, keep as it is. Side square. What is the side given in the question? 5 centimeter. Very simple. Just substitute the value of 5. 5 square. So 6, 5 square. How to find? 5 square is 5 into 5, which will give you the value 5 5s are 25. So 6 into 25. If you multiply 6 into 25, we got the value 150 centimeter square, because square units no centimeter square. That's it. So if a side value is known for a cube, by applying the formula, we can simply find the total surface area of the cube. Next, we are going to find the lateral surface area. Lateral surface area of the cube. What is the formula? It will include 4 faces. So 4 into sine square units. 4 into sine square units. That is 4 into, what is the sine? 5. So 5 5s are 25. So 4 into 25, which is equal to 4 is 4 into 25. The value of 4 into 25 is 100. So 100 centimeter square is the lateral surface area of the given cube. Next, what we have to find? Length of the diagonal. Length of the diagonal. Again, we have to recall the formula. What is the length of the diagonal? Is side into root 3. So, diagonal, length of the diagonal. Length of the diagonal. The formula is side into root 3 units. So, what is sine here? It is 5. So, 5 into root 3 units. That's the answer. So, for root 3, we can find the square root. Okay, root 3 is a prime number. So, we will get the square root value as 1.732. The standard form for root 3 is 1.732. If it is asked in the question to use root 3 means, we can evolve it and find the answer. Otherwise, complete the answer as 5 root 3. Okay, so see how simple it is. For a cube, if you remember this formulas, what is total surface area, lateral surface area, length of the diagonal, and cube, remember the formula. By knowing the side, just by substituting the values, we can get the area. Okay, so here see, total surface area is 6 into side square. So side is 5. 5 is 25. 6 into 25 is 150. Likewise here, 4 into side square. So we got the value as 100 centimeter square. And that side into root 3. Side value is 5. 5 and root 3, we can't multiply that, so conclude the answer is 5 root 3 units. Okay. Now in exercise 16.2, already we have completed up to the 9th problem. Now we are going to solve the 10th problem. See here the question: a wall 12 meter long, 9 meter high and 10 centimeter wide has to be built from the bricks 40 centimeter long, 6 centimeter wide and 2.5 centimeter high each. How many bricks required to build this wall? Okay, well, constructing the wall, we will use many bricks to construct a wall. Based on the height and breadth of the wall, the number of bricks is required. Also, based on the side of the brick, what is the length of the brick, height of the brick, based on that also the requirement is there. So, here they gave the wall, to which height they are going to build the wall. What is the length of the wall, height of the wall and breadth of the wall. And for each brick stone is there, no? For each brick they gave the length, breadth and height. What we have to do is, to construct such wall in this height, in this length and breadth, such wall, how many such bricks are required? That's what we have to find here. Okay, how to find this? Imagine, based on the length only the bricks are, based on the length of the wall as well as the length of the brick only, the number of requirements is we can find. The same way, what we are going to do is, we are going to find the total volume of the wall. Okay, that will be because if you construct the wall finally and if you see this, it will be the shape of the cube wall, isn't it? By seeing the measure, we can say that the wall is in the form of the cube wall. In a cuboid shape, each we are filling, no, that is the capacity. Each brick we are filling, no, that will gives you the capacity. So, if you find the volume of the wall and divider, if you divide by the volume of the brick, finding the total volume of the wall and dividing the volume by this, the volume of the each brick, we will find easily how many bricks are required to construct this wall. This only we are going to use here. So for that, first we have to find the volume of the wall and the volume of each brick, no? So see here. They gave the measures for both wall as well as brick. Both are in the shape of cuboid only, isn't it? Wall is also in the shape of cuboid as well as the brick also in the shape of cuboid. So we are going to find the length, whatever it is given here. See here, by seeing the question here, see the first two only is given as meter, other thing is in the form of centimeter. While calculating each and every measures what we are going to substitute should be in the form of same unit. For example, if first measure is centimeter, second centimeter means convert all the measures to centimeter. So 1 centimeter unit and other meter unit you cannot calculate the different units in same formula. Okay, so change the units to single, maybe to meter or to centimeter. here I am going to change everything to centimeter, because see apart from first to measure, all other are in centimeter. Okay. Also we are going to find the number of bricks. Better to convert in the form of centimeter. So first, what is given? Long. Long. The wall is long means here we can consider it as a length. Okay. The long can be taken as length. Length of the wall. Length is equal to 12 meter. From meter to centimeter, how to convert it? Yes, 1 meter is equal to 100 centimeter. You have to keep in mind always the unit conversions. Okay, so 1 meter is equal to 100 centimeter. So we have to multiply by 100. So that the value will be 1200 centimeter. Okay, so meter to centimeter we converted. The next one, height. Height means it represents the height of the wall. It represents the height of the wall. So height. Height is equal to 9 meter. Again to centimeter I have to convert. So multiply by 100. So 900 centimeter. The last value is wide. Wide can be taken as breadth. Width or breadth. So we can take it as breadth. Breadth is equal to, already it is in centimeter only, so no need to change. So keep as it is in centimeter. Now come for the brick. What are the measures given for brick? The brick is 40 centimeter long, 6 centimeter wide and 2 centimeter high. So length of the brick. So we can take the length is equal to 40 centimeter and height. Height is equal to 2.5 centimeter and breadth equal to, what is the breadth? 6 centimeter. So see, if you separately writing the measures like this, it will be very easy for you to substitute. Okay. So see, for wall, I taken the value separately and bricks have taken the value separately, and I told that 2 things are in meter, other things are in centimeter. We can't substitute different units in the same formula. So we are making all the units to the centimeter. Yes. Now, what I said, we are going to divide the volume of the wall by volume of the brick to find the number of bricks. Further, first we are going to find the volume of the wall. Okay, so how to find the volume of the wall? What is the shape of wall here? It is in the shape of cuboid. By given, we can understand the shape of the wall here is in the form of cuboid. This is solid body, not cuboid. So volume of wall. We can take the formula volume of the cuboid. What is the volume of the cuboid formula? Length into breadth into height cubic units. Length into breadth into height cubic units. So what is the length of the wall? See here, what is the length of the wall? 1200 into 900 into breadth is 10. Isn't it? So if I multiply all those values, we will be having 0, 1, 4. So multiply just, we are having only zeros now. So 12 into 9 will be having 108 and add all the zeros. So which is equal to centimeter square cube, because we are finding the volume of cubic units. So we are having that. Okay. Next, volume of one brick. Volume of one brick only. Again, the brick is also in the shape of cuboid. Here also we have to use the same formula, length into breadth into height. What is the length? 40 into, what is the breadth? 6. And the height is 2.5. The height is 2.5. So if we multiply, the value is 600 centimeter cube. The value you will get is 600 centimeter cube. Now we got both the volumes, volume of the wall and volume of the brick. Here what we have to find? We have to find the number of bricks required. So number of bricks. Number of bricks required equal to volume of the wall by volume of one brick. So what is the volume of the wall? 4 by 600. If we cancel 2 zeros, will get cancelled, and if I simplify by 6 here, it's okay. Write the remaining number, then simplify that. So zeros means we can cancel easily now. So 2 zeros I cancel. The remaining will be 108 000 by 6. If I simplify by 6 directly, 166, remaining 4, 8 6 are 48. So the value is 18,000. The value is 18,000. So how many bricks are required to construct the required wall? They gave some length and breadth and height of the wall now. To construct the wall as it is, the number of bricks they required is 18,000 bricks. Okay, so whenever you are having a situation problem like this, okay, we are going to construct a wall or we are going to fill the tank with this object. For that object they gave the one object. For example, here the object is brick. One brick volume is, if you find this, by getting the total volume of the wall, by getting the total volume of the wall dividing by one volume of the brick, we can find the number of bricks required. This concept you can use in other situation problem also whenever you are getting the situation like this. Okay, so understood it? Yes, we'll solve the next problem now. Now see the 11th problem, children. It is also a practical problem. See that a field is 18 meter long and 9 meter wide. From one corner of the field, a 3 meter long, 2 meter wide and 1.30 meter deep pit is dug out. The earth came out is spread over the remaining field. Find the increase in the height of the field. What is the situation given here? There is a rectangular field. In that one corner, from one corner they made a pitch. Okay, for the pit they gave what is the length, breadth and depth. Depth here represents the height. Okay, for saving the rainwater or putting the fertilizer, making the fertilizer to compose, what they will do? They will make a pitch. Like that situation only given here. At one corner of the pit, they made a pit. Okay. From the pit, if they make a deeper, what is it? They are making a hole, they will make the earth out now, they will make the earth out. So, that earth what they are making out is spread over the remaining field. That whatever they are taking out now, that sand or the earth what they are taking out, they are spreading over the remaining field. Okay. So, okay. Now, they are asking what is the increase in the height of the field. Okay, if the field was little flat, if we spread some sand over it, it will give some increase in the height of the field now. That height only we have to find here. Okay, so see the question, understand the question again. There is a rectangular field at one corner of the field. Okay, there is a rectangular field. At one corner of the field, they make a pitch. Whatever the earth where they dug out from the pit, what they did? They spread it over the other remaining part of the field. They spread it over the remaining part of the field. If we spread over, there will be some increase in the height of the field. That height only we have to find here. Okay. Now, given. First we are going to see what is the given for the rectangular field. For the field. What is the length of the field given here? The field is 18 meter long. The long will be represented as length. So 18 meter. And 9 meter wide. 9 meter wide is given as the breadth of the field. Okay. First, we have to know the remaining area. We have to know the total area of the field. From that, we have to know remaining area of the field. If we know that apart from this pitch, if I know the remaining area only, we can calculate what is the height we can spread it. Okay. So first we have to calculate the remaining area of the field. For that, how to find? Think once. How to find this remaining area of the field is area of the total field minus area of the pit. If you find the area of the total rectangular field minus if I subtract this area of the pit. If this blue region from that we can get the remaining shaded portion. That's what we are going to use here. So first we are going to find the area of the field. What is the shape of the field? It is in the rectangle shape. So what is the area? Length into breadth square units. Length into breadth square units. What is the length here? We are having 18 into breadth square units. So length is 18 and breadth is 9. If you multiply 9 8 is 72. 2 9 7. 1 into 9 plus 7. So 16. 162. What we are the measure we are having? Meter. So meter square. So area of the total field. Whatever the rectangular field totally the area is 162 meters square. Now we are going to calculate the area of the pitch. Area of the pit what we have dug out. This area we are going to find. So for the pit, what do they have given? The length is 3 meter and the breadth is 2 meter. Length is 3 meter and the breadth is 2 meter. So again, the pit is also in the form of rectangle only because they gave the length and breadth. So 2 into 3. 2 3 is a 6 meter square. 6 meter square. So in our hand we are having now the area of the total field and area of the pit. But the question here is area of the remaining field. Okay. So how to find the area of the remaining field? Area of remaining field is equal to total area. What is the total area? 162 minus area of the pitch. What is the area of the pitch? 6. So 162 minus 6 will be 156 meter square. So the remaining area of the field apart from pit is 156 meter square. In this area only we are going to spread out the earth. Now, how to find the height of the earth increased? How to find is how we are going to find this. Now, the volume of the whatever the volume of the earth we are taking out, the same volume only we are going to spread out in the field. Using this concept only we are going to find the height increased. So here what we have to compare is the volume of earth that is dug out is equal to the area of the volume spread out, equal to the area of the volume spread out. That only we are going to equate here. So first we are going to let h be the height increased. Let h be the height increased. So as I told before, area of the earth, volume of earth dug out should be compulsorily equal to the volume of earth spread. So this volume only, because the same whatever the earth we are having in our hand after digging out, that earth only we are going to spread out. So the volume of earth dug out should be equal to the volume of earth spread out. So we are going to equate this. Volume of earth dug out. Volume of earth dug out means how much deep we are digging out, that volume. Okay. So the pit so the volume of the pit is equal to the volume of the earth dug out. The volume of the pit is directly equal to the volume of the earth dug out. So volume of the pit. What is volume of the pit? Pit is in the shape of rectangle only, no? So length into breadth into height. So see what is the volume of the pit? 3 into 2 into 1.30 is equal to volume of the remaining field, equal to, because we are going to spread out the earth in the remaining field only. Volume of the remaining field. Volume of the remaining field also length into breadth into height. But already we are having the area of the remaining field as 156. We are finding only height because the area is the dimension length into breadth. Already we are having that. So for length and breadth we are directly taking 156 and the unknown value h we are repeating as h itself. So it is taken as h. Now we have to multiply. Okay, we have to multiply and taking the value to the next side of the equation we will get the value of h. Now if I multiply this, we will get 7.3 is equal to 156 into h. We want to find the value of h only, no? So h is equal to 7.8 by 156. If you simplify this, we get 1 by 20 meter. 1 by 20 meter. But it is in fraction, so change it to centimeter. 1 by 20 meter, how to change it as centimeter? So 1 by 20 into 100. Because to meter to centimeter, we have to multiply by 100. So if we simplify, we will get 1 to 2 and 5 to 10, which is equal to 5 centimeter. Because while we can give the answer in meter only, no? Yes, but this is a fraction of 1 by 20 meter. So it is a very small measure, better to change in the centimeter. So multiplied by 100, we got the value as 5 centimeter. So if the dug out earth is spread in the remaining field, the field will increase in the height of 5 centimeter. It will increase in the field height of 5 centimeter. Okay. So I hope you understood this problem. Now we will move to the next problem. The next problem, children. A metallic cuboid is 75 cm long, 20 cm wide, 18 cm high. It is melted into a cube. Find the side of the cube. What is the question here? A cuboid shape is melted and made it as a cube. If we are converting one object, for example, if we are having a clay, okay, in clay we will do the different shapes. We will play, no, isn't it? First, if we are making a tree, then we are making using the same clay, you are making the flower. What is the common between these two? Okay, the same quantity of clay, okay, we will use for tree, but may the height of the tree, breadth and length will be different. For the flower, it may differ in length and breadth. But what is common in both the shapes? The volume of the clay what we are using. Okay, the same concept only we are going to use here. Here, a metallic cuboid is changed into the cube. Okay, maybe its size may differ, but what is common here is the volume. Whatever the volume of the cuboid is, that the same thing will be converted as a cube. So we are going to equate the volume of cuboid to the volume of the cube, and we are going to find the side of the cube. First, write the given. Whatever the given things here for a cuboid. For a cuboid, length is equal to 75 cm long, that is length is 75 cm wide. Wide we can take it as breadth. Breadth is equal to 20 cm and 18 cm height, that is height. Height is equal to 18 cm. So from one shape they are converting to the other shape. So whenever you are reshaping any object to other shape, keep in mind always the volume is equal. Okay. So here volume of cuboid is equal to volume of cube. It is equal to volume of cube. What is the volume of cuboid? What is the volume of cuboid formula? Length into breadth into height. So we are having length into breadth into height. And volume of cube. Volume of cube is sine cube. Volume of cube is sine cube. Here we are going to identify the side of the cube only. For that, first we have to substitute the values of cuboid. What are the values of cuboid? 75 into 20 into 18. 75 into 20 into 18. If you multiply, you get the value 27,000. You get the value 27,000 is equal to sine cube. It is sine cube, but we want to find the value of sine. That means we have to take the cube root of 27,000. We have to take the cube root. If there is square, must we will take the square root. No. Likewise, here we are having cube, so we have to take the cube root of 27,000. So we have to identify the cube root of 27,000 is equal to sine. So what is the cube root of 27,000? It is easy, no? What is the cube of 27? Cube root of 27 is 3. 3 3s are 9, 9 3s are 27, and 27,000 means we will get the cube root as side is equal to 30. Side is equal to 30 centimeter. See, cube root of 27,000 is 30. So side is equal to 30 centimeter. So this problem will help you in solving the many other problems. Okay. So keeping the concept mind, from one shape if you are reshaping to the another shape. Okay. For example, from sphere to cube, or cuboid to cube, or cube to cuboid. What is the common thing there means the volume. From which shape to which shape you are changing, the volume of that shapes will be equal. Using that concept only, we got the side of the reshaped cube as 30 centimeter. Okay, children. So today in this class we have discussed the formulas of cube. Okay, is what total surface area? It is 6 into side square. Lateral surface area 4 into side square, and diagonal, length of the diagonal is side into root 3, and volume is side cube cubic units. And before, in the previous class we have discussed about the cuboid. Okay, so in this exercise we are having only the shapes or lateral surface area of of cubes and cuboids. With this, we have completed the lateral surface area, total surface area, lateral surface area and volume based on the problems, cubes and cuboid. So what you have to do is you have to read the formulas clearly. Okay, take a chart or any A4 sheet, write the formulas and paste in your study room, so that by seeing that regularly you can recall the formula in your mind easily. Okay, so do that, read the formulas and solve the problem. Okay, so based on the same manner you will get your assignment problem also. Complete your assignment problem and post in your group. Thank you children.